Hello everyone, today I'm going to be showing you how to solve problems 15 to 20 of the AMCA in the year 2019. The problem of problem 15 says, on a beach 50 people are wearing sunglasses and 35 people are wearing caps. Some people are wearing both sunglasses and caps. If one of the people wearing a cap is selected at random, the probability that this person is also wearing sunglasses is 2/5. If instead someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? So we can say that since we know that 2/5 of the people wearing caps also wear sunglasses, that means there's 14 people wearing both because 35 times 2/5 equals 14. So we know that 14 people are wearing both caps and sunglasses, and it says if someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? So the final answer is 14 divided by 50, giving us 7/25. And that is our answer B. Problem 16. Problem 16 says, Chang drives 15 miles at an average speed of 30 miles per hour. How many additional miles we have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? So we can use the answer choices and see that 110 is the only one that can be evenly divided by 55. So we can set up our equation like this. 15 over 30 plus 110 over 55, and this is 1/2 and this is 2, so this equals 5/2. Now we know that average speed is equivalent to time over distance, and we know that our time is sorry, my bad. It's not time over distance. It's distance over time. So we know that average speed is distance over time. And we know that our distance is 15 plus 110, giving us 125. And we know that our time is 50 because we want to average 50 miles per hour. So this also gives us 5/2. And since these two are equivalent, then D 110 works and is the correct answer. Now we move on to problem 17. Problem 17 says, what is the product of this huge bunch of fractions? And this looks tricky at first, but we can realize something pretty interesting. For example, we can take these three, and we can realize that these two threes cancel out, and these two threes cancel out. These two fours cancel out, and these two fours cancel out. And then all the way to here, this 98 and that 98 cancel out, and these 98 cancel out. So we can realize that after all these cancellings, we are left with 1/2 right here times 100/99 over here. And we can simplify this. We can cancel those out to equal 50/99, giving us B. If you notice this pattern, then this question is actually very simple. Problem 18. Problem 18 says, the faces of each of two fairy dice are numbered 1, 2, 3, 5, 7, and 8. When the two dice are tossed, what is the probability that their sum will be an even number? Again, this looks tricky, but a very simple way to do this is actually just to make a chart. So we can make a chart like this, and it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And we can say that this is 1, 2, 3, 5, 7, and 8. 1, 2, 3, 5, 7, and 8. And we can just add these. So 2, 3, 4, 6, 8, 9. Now, if you're running low on time, you shouldn't use this method. But if you have the time and you want to guarantee the correct answer, then this method works quite well. Oh, yeah. But like in the real test, if you have like 3 minutes left, you have to like rush kind of, because that would take a lot of time to draw the chart and all. So you can see that I'm almost halfway done. I'm gonna try to speed up. Yeah, one moment. So we can continue like this, and we can count out how many there are. Now, like I said, there's obviously a faster way to do this, but this way, if you have the time, it's a interesting option. So I'm almost done. And here we have it. So the amount of even ones out of these 36, we can circle in different colors. So these are even. Oh, that's not even. Sorry. Okay, so this one, this one, this one. So you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And there's 36 total. So our answer is 20 over 36, giving us 10 over 18, which is 5 over 9. So our next problem, problem 19. It says, in a tournament, there are 6 teams that play each other twice. A team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. After all the games have been played, it turns out that the top 3 teams earn the same number of total points. What is the greatest possible number of total points for each of the top 3 teams? So we know that each the team earns 3 points for a win. So there's 6 teams: A, B, C, D, E, F, and that's it. Go. So let's say A, B, C are the 3 top ones. Then they all B, D, E, F both times. So that gives, and they each beat each one. So that gives 3, 3, 3. And since they play each other twice, that gives each team 18 points. Now for the matches in between each other, so like A versus B, A versus C, and B versus C, we want to guarantee the most amount of points. So let's say they all tie each other. If they tie each other, then that gives you 1 plus 1, and you play each other twice, then that gives you a total of 4 points. So that would give you a highest of 22. But let's say that they beat each other, that they beat a team twice, and then that team beat another team twice, and that third team beats the first team twice. Well, that gives you 3-3, which is an extra 6 points, which is 24, giving you C. So the next question, problem 20, says, how many different real numbers x satisfy the equation x squared minus 5 squared equals 16? So this problem is a bit tricky because you might forget that like negative 4 squared also equals 16. So there's two possibilities. X squared minus 5 gives you 4, or x squared minus 5 gives you negative 4. So let's start with x squared minus 5 equals 4. That means x squared equals 9. So there's two solutions for x, negative 3 or positive 3. Now let's say x squared minus 5 equals negative 4. Then there's also two solutions. Because x squared has to be 1, so it could be negative 1 or 1, giving you 4 solutions, D, for the final answer. I hope you liked this video. If you did, please like and subscribe down below. If you have any questions, feel free to comment down below. And good luck on the AMCA in the year in this year 2020. Thank you. Bye.